everyone, welcome. So in today's videos, we are on page 30 in our chapter 2 packet. We will be covering function operation. Again, when you're done with this video, you are asked to come back to our virtual classroom in the Zoom link, okay? So what we're going to be looking at in this section is we're going to be taking different functions, if you can see here, and we will be doing different operations. So the 4 operations of math are adding, subtracting, multiplying, and division. We might cover division, we might leave that out and wait for chapter 4 when that comes back. So we'll just see. The other thing that we're going to talk about is the domain. So that, remember, domain are all the x values. And so what we want to start to look at is, can we look at a function and know when it has a restricted domain, which means normally when domain is x and we can pick any number for x, we might be limited to the numbers that we can pick for x because they won't work in the problem. And specifically why they won't work in these problems is because you would be having a fraction, for instance. So let's just get started. So we're going to start out with 2 functions, f of x, which is x cubed, and g of x, which is x squared. And we're going to walk through their math. So just real simple, I should take f of x, which is x cubed, and I should add to it x squared. And that's it. That's all you can do. So you can't actually add these because they're not like terms. So one thing we're going to start to focus on throughout the rest of the year is what you can actually do with adding, subtracting. Because adding and subtracting is very, very picky with what you can add or subtract. And that's something you should be aware of just from elementary school. So when you're adding a problem like this, you would have rewritten it and lined up the ones, because the ones can only add with the ones and the tens can only add with the tens. You wouldn't have done this because now you're taking a ones and adding it with the tens. So adding, subtracting is very, very picky, okay? So this is it. This is as far as I can go, and I have a new function, all right? So now what we're going to do is we're going to multiply these functions. So I'm going to take x cubed times x squared. And this is kind of reaching back into freshman year, your exponent operations. And multiplying is a little bit more forgiving with the operations that you can do. This says that you have 3 x's multiplying. And then this one says you have 2 x's multiplying. So how many do you have altogether? You have 5 x's. So what you would have learned middle school and freshman year is that when you're multiplying and your bases are the same, they both have to be x, that you can add the exponents. All right? And then the last one, we're going to divide them. So x cubed, and I'm going to divide it by x squared. Again, if you think about what this means, I have 3 x's on top and 2 x's on the bottom, and then they can cancel out. So when we're done, we have x to the first. Or the exponent rule says that when you're dividing with the same bases, you can subtract the exponents. So if you're multiplying and your base is the same, you can add them. When you're dividing, you can subtract them. So let's talk about the domain. Are there any numbers where I could potentially, when I pick them for x, run into an issue? So if I tried to type something into my calculator, I would have an issue. And the only area where we're going to have an issue for us right now is if you are dividing. Because if you remember, there's one number you can't divide by, and you can't divide by 0. So here, because I don't have a fraction, I don't have x in a denominator, I can pick any domain that I want. So we would say something like this, all real numbers. And if you graphed it, you would see that as well. If you graphed x cubed plus x squared, you would see that the x's keep going left and right. You would see that we could put those infinity signs. The same with x to the 5th. No problem, no domain issue. I can make this all real numbers. All right, so I paused the video and I'm just going to point this out to you. So this is the function x cubed plus x squared. When you do check for domain issues, if you do want your calculator to help you out, you need to put in the unsimplified version. So here we couldn't do anything, we couldn't simplify it. But if we did our arrows, we would have x's negative infinity on this side and x's infinity on this side, and that means all real numbers. If we put in the other one, and again, I am putting in the unsimplified version. I'm going to be putting this in, all right? You're going to see it's very similar. I would have x's negative infinity, x's infinity. But when we put in the final one, so I'm going to pause here for a moment. So here's the final one. And so I did put in the unsimplified version, x cubed, x squared, and it does look like a line. It looks like the line. This is very similar to y equals mx plus b. If we wrote this, this would be like y equals 1x plus 0, because when you don't see an exponent attached to your x, it is a first power, so this is why it's looking like a line. And it looks like it's continuous, which means there's no break to it, but there's actually a little break to it, and unfortunately the calculator doesn't do the best job. But if you look at the table, you're going to see when you choose x to be 0, that you get an error message, because I can't have x down here in the denominator. I can't take something in the numerator and divide it by 0. So we have a domain issue. So again, whenever you have a fraction, you will most likely have a domain issue. So here my domain is everything but x. So one way I could write that is x just can't be 0, but if I want to write what it is, which is what we've been doing, it can be anything from negative infinity up to 0. I'm not going to include 0, so that's why I'm going to put it in parentheses, and then 0 to infinity. So by putting these parentheses here, I'm saying I'm not going to include 0. I'm going to get really close to 0, but not include it. So this is what it can't be, but this is what it can be. So when we are in the section and you see a denominator, you need to stop and check for its domain issues. So let's run through some more of these problems. All right, we've got two new functions, 4x cubed, 8x squared. I'm going to make a new function, h of x, and I'm going to multiply these. So 4x cubed times 8x squared. And again, multiplying, you can do a lot more with multiplying than you can with adding and subtracting. With multiplying, we can multiply the things that are similar. So 4 times 8, there's 32, x cubed and x squared, which is just what we had up here. That means there's x to the 5th power. Don't multiply the exponents, add them. And then this is it. I never had a fraction. I never had a domain issue. So this, I should have put this inside the box. So there's my new function, h of x. Now, if I do want to check it on the calculator, I should type in the unsimplified version always. So what's the domain? There is no domain issues. I don't have a denominator, so my domain can be all real numbers. Or you can do the negative infinity to infinity. All right, now what we're going to do is we're going to evaluate h of negative 1 if possible. So we're going to take negative 1 and we're going to put it in here. And you are more than welcome to use your calculator to do this. Just start to think about what type of answer you have. If you have a negative number to a power, you could result with a negative number. So with an odd power, you will always result with a negative number. And the reason why is when I start multiplying negative 1, you know, if I have an even amount of numbers, those become positive and those become positive. But when I have an odd amount, this one extra negative is going to force this to become negative. When you do type it into your calculator, make sure you wrap that number, that base, in parentheses, just like you see it here. So anyway, I would have 32 times negative 1, because negative 1 to the 5th power is negative 1. And then when I multiply these, I get h of x. Okay. The other thing I could do, again, is I could put this into the graphing calculator, and then I could go to my table and check to see when x is negative 1. All right, now what we're going to do is find another function, k of x, and we're going to divide them, g of x by f of x. So k of x will come when I take g of x as my numerator, f of x as my denominator. I do want to simplify it. So as far as a fraction goes, just like I could multiply 4 and 8, I'm going to divide 8 and 4 and get 2. And this time, if I wrote this out, you know, the long way, and then these cancel out, I will have x in my denominator. So this is my new function. You can subtract. What I always recommend is you subtract the easiest way possible. 3 take away 2, which is 1. And then when you have to decide where is that one x left, there are more x's in the bottom than there were in the top, so that's where our extra x is going to end up. So this is my new function. It's called k of x. Okay. Now I'm going to find the domain. Again, whenever I find the domain, I always want to look at the unsimplified version. So I just want to make sure that no matter what I pick, that 4x cubed cannot become 0. And then I would just solve for something like this. So to get x alone, I would divide by 4. And then when I take the cubed root of 0, I can't have 0. So there's my domain. This is what it can't be. We want to get used to writing what it can be. So it can be negative infinity up to 0. Don't include 0. And then 0 to infinity. So again, this is what it can't be, but this is what it can be. And now what we're going to do is we're going to evaluate k of 5 and k of 0 if possible. So with k of 5, I'm just going to put 5 in there. Okay. So it's going to go, again, k of x, if you remember, was 2 over x. And that means 5 should go in here. And so when I'm done, my function k, when I make that x worth 5, gives me 2/5. Now, when I try to put 0 in there, this is why you see this if possible part. You can't divide by 0. So k, when x is 0, is no solution. Technically, you would say it's undefined because you can't divide by 0. So if you tried to type into divide by 0 in your calculator, you would get this error message. So again, we're just adding, subtracting, multiplying, maybe dividing. I think we're going to see how far we get. But when you see division, check for domain issues, okay? And I should already know, I shouldn't even have to do this math, that 0 wasn't going to be possible because we said that here, all right? All right, let's see what else we got. Let's just try a few more. We've got 2 new functions, so f of x and g of x, and I'm going to subtract them. So I'm going to take g of x. So let's see, 2x cubed. There's a lot, so I'm going to wrap it in parentheses. And then I'm going to subtract f of x. So here we go. It's subtracting. And I do have to be careful because I'm subtracting everything in here. I do want to subtract my like terms. So when I have an x cubed here, I will try to subtract an x cubed here. And actually, now that I'm seeing this, I do want to change this problem. Let's change this cubed here. Let's change that to a squared. Okay. All right, changing that to a squared. So first of all, when I take 2x squared, I'm going to have to subtract this x squared, which is like a 1x squared. So 2x squared, take away x squared, that's just 1x squared or x squared. Now, when I take 3x and I'm supposed to subtract this already subtracting 4x, remember, when you subtract, you can treat this like a negative. That's like you adding a positive. So 3x subtracting, this is actually like 3x adding 4x, which would then make it 7x. And then when I take 2 and I subtract this 3, this gives me -1. To me, that's a little confusing. So what I like to do, since I'm better at addition, is I go to the subtraction that's in between my 2 functions, and I turn it into addition. And then I go through and I take the opposite of each of these terms. So the opposite of 1x squared is a -x squared. I just change one thing about it because an opposite is just changing one thing. Instead of subtracting 4x, I add 4x, and instead of 3, I have -3. And then when I do this, I could look at this as 2x squared plus -1x squared, get this, 3x plus 4x, and get 7x, and 2, and add with -3, and I get my subtracting 1. So anyway, there's my new function. I have no fraction, no denominator, so my domain is all real numbers. And I should have written that in all caps, but I wasn't paying attention. So now I'm going to put -2 in, and I always put it into this version. So I'll be putting x is -2 into here. So -2 squared plus 7 times -2 minus 1. And I want you to notice that I'm wrapping it in parentheses because if you are going to use your calculator, this is very important. If you don't put this -2 in parentheses, your calculator will be reading it differently. So anyway, I get 4. This gives me -14. I subtract 1. Again, you could just type this into your calculator, but here I get -10. -10 take away 1 is -11. So there is my function. All right, let's do the last 2 super quickly. So now I'm going to be multiplying, and this is going to take a little bit more work. So x squared minus 4x plus 3, and it's going to multiply to 2x squared plus 3x plus 2. And this is where they're right next to each other. The neighbors are going to meet the neighbors. So the first person doing all the meeting is x squared. So when I multiply these, I get 2x squared. When these meet, I get 3x cubed. I'm sorry, not x squared here, x to the fourth, my apologies. But this is 3x cubed, and when these meet, I get 2x squared. So now who's going to do the meeting is this negative 4x. So negative 4x is going to go over and meet everybody. So when negative 4x meets this, I get negative 8x cubed. I'm going to stack it under my other x cubed because they will become like terms that I have to combine later. Negative 4x with 2 is negative 8x. Oh, sorry, I'm really messing up here. I jumped again. Not yet. Negative 4x with 3x, sorry about that, is negative 12x squared, and then negative 4x with 2 is negative 8x. I will try to cut down on those mistakes. And the last one. It's now 3's job to go meet everybody. So 3 meets 2x squared, that's 6x squared. Again, I'm stacking those like terms. 3 meets 3x, that's a 9x. And 3 meets 2, and it gets to start its own column. And now I can just add these up. So here we go. This becomes minus 5x cubed. So when I add these, I get negative 10. Negative 10 with 6 is negative 4, or minus 4. Here I get 1x, or you could just put x, and 6. All right, last one, and then the video is done. So we're going to evaluate f of negative 1 and g of 2. So what I'm going to do is put negative 1 into here. I'll put 2 into here, and then I'm going to add them up. So let's start with this one. Again, always put that number in parentheses, especially if you're going to be letting your calculator do this work for you. So there's minus 4, in parentheses is negative 1, plus 3. And then here comes my other function. So let's just put this like in a bracket to separate these out. There's f of 1. And now here comes g of 2. So it's going to be 2, and then in parentheses, 2 squared, plus 3, in parentheses, 2, plus 2. So this is one big math problem. Order of operations. I'll do my exponent first. We'll start here. There's 1. And then I would have subtracting. Again, I don't like subtracting, so I'm going to add and do the opposite of 4 and make it negative 4. And then when I multiply these, I get 4, add the 3, so all of this becomes 8. Or you could just type this into your calculator. As far as this goes, I'll do my exponent first. There's 4, and 4 times 2 is 8. Multiply those, I get 6, along with the 2. When I add those up, I get 16. So when I'm done and add these functions up, my answer is 24. And that is it for our video. So again, when you're done, please come back to our Zoom.